And there we go. I am Jasmine Toole. I'm the Soils Technical Lead and Knowledge Exchange Coordinator on the CHCx3 project. And today our two speakers are Ian Shield, who is an experienced agronomist. He is the head of long-term experiments and agronomy, and he is the chair of the Farm and Field Experiments Committee at Rothamsted. And our second speaker is Dr. Nathan Morris, who is a soils and crop specialist at NIAB, and he runs several long-term experiments across East Anglia, including the Star and Saxmundham experimental trial. So to start with, if I can pass over to Ian for your presentation, please.
Okay, good afternoon, everybody. I will see if I can share my screen. Is that showing for everybody?
Yeah, we can see it. Thank you.
Yeah, so a little bit of an imposter here. I'm presenting the initial slides introducing the project on behalf of Lydia, who unfortunately can't be with us this afternoon. So we have a little introduction to this project, the Centre for High Carbon Capture Cropping. It's a fairly big project with a lot of partners involved. It's funded by DEFRA and the Farming Futures, and it encompasses crops, soils, and uses and end value in those crops in terms of capturing carbon. The list of partners is long. There are, I think, was there 22, somebody said. Quite a management task for those managing the project, a big group. The project is split into work packages, and you can see there the different cropping types that are involved. We're here today talking about cover crops specifically, and certainly in what I mentioned, there will be a bit of tillage. We've got the fiber crops, perennial cropping for food, feed, and forage, and then we also have perennial cropping for biomass. Soils covers everything really, because we're looking at carbon in soils across all the different cropping types, and there's a bit of crop genetic improvement for some of the normal crops that are in there, and of course the overall objective to be a knowledge hub for these ideas and concepts for carbon capture on farms. So the cover crops that we're talking about today, this is a general slide that for the project, and you know, there's a lot of questions to be asked as to whether it's worthwhile. Should you do it? Should you not? And so many factors involved in making that decision. What the use would be, would it justify the expense and the additional work of establishing these crops? And does it fit in the rotation? And will it do harm to the crops that are making the money, or hopefully making the money? Not always. So we are doing some work to address these questions, and we can give you a flavor of what we're doing. Not always, we're not promising answers. I'm just able to show you what we're doing to try and start to address a few of these things. So importantly, if you want to make contact with the project, if you want to follow what's happening with the project, there's an email address to actually get in contact. There's a website to follow things, and you can sign up for the newsletter and keeping yourself informed of events such as today's webinar, and that's only part of a series on many subjects across the project. So plenty of ways to keep in touch and keep yourself informed as to what's happening. So moving on, Rothamsted's contribution to this comes from something which it got a working title and nobody ever bothered to give it any other title. So it is called the Large Scale Rotation Experiment, but it does cover, as you'll see in a moment, more than just crop rotations. And obviously it has a cover crop component. We're doing it on 2 sites. This one is Brimsbarn, near Borough of St Edmunds, Suffolk, and that's on a fairly light sandy loam. And then our main site at Harpenden in Hertfordshire, somewhat heavier soil, acidic clay. So we've got the contrasting soil types there, but not really contrasting in terms of weather conditions or anything such, just soil. So the crop rotation aspect, there's 3 crop rotations. A very simple one, just 2 weeks in rape. A 5-year rotation, which diversifies a little bit with a spring legume, a spring cereal, and then something that's somewhat more out there, a little bit more adventurous, and see what changes we can make by introducing it. A 2-year lay as it was, that has now been replaced with a 2-year legume fallow to just lengthen the rotation, increase the diversity, and see where we can go with that. The whole thing is a systems approach, so you don't study and get results which indicate in any one activity. You can see there are organic amendments added to these plots, which of course will also have an effect on soil carbon, and the cover cropping, which comes pretty much every time you have a spring crop coming up in the rotation. And of course, the 2-year legume fallow could be seen as a cover crop. Depends how you want to make your definition of a cover crop. 2 cultivation regimes over the top of that. With all these treatments, all combinations are present in all years. So it's what's called fully factorial. Thorough soil disturbance, still using plough, and zero till, or as close to zero till as we can get, admitting that we do on occasion have a bit of soil movement. Below that, what we call a second level of treatments. As I said, we've got the organic amendment, which is a compost, brought in compost going on just once in the 2 shorter rotations, twice in the longer rotation. We have an aspect of smart crop protection, which is something, a program that was running at Rothamsted for several years as this piece of work began. We won't go into detail of that today. That's another piece of something we could talk about and have a webinar on its own. So the cover cropping in the 5-year rotation, we're keeping it simple. It's Phacelia and black oat. We didn't want to put brassicas into a 5-year rotation, which included oilseed rape, so we left it out. In the 7-year rotation, where we don't grow oilseed rape, we have brought in 3 different fodder radishes, a much more complex cover crop mixture there with a clover. There's a vetch, 2 legumes going in there, black oat again, and niche. As I said, we did start with the 2-year grass lay. We've moved away from that now, and we're in the 2-year legume fallow, and we have 4 legumes in there. We've got lucerne, white clover, yellow trefoil, and greater bird's foot trefoil, which makes quite a nice mix for that one. So, as you might imagine, we draw in all the different disciplines to make studies of very specific aspects. Soil microbiologists very interested in how the soil microbiome is changing or potentially changing as time goes by with these different treatments applied. Soil penetration resistance, and also things like bud density, of course, with zero tillage or absolute minimal tillage, and thorough soil cultivation. And of course, lots of soil cores to keep a track on soil carbon and the basics, nutrition and pH. As it's a long-term experiment, it needs that constant monitoring for the usual. Soil seed bank being assessed by the germination method in the glasshouse. See what we're doing obviously we're recording weed populations that are visible, that have germinated in the crop, and also looking at the seed bank. That's a plot of the penetration resistance on the right at Broom's Barn, showing a fairly dense, hard to penetrate layer at about 40 centimeters, but doesn't seem to be having a serious effect on productivity. Importantly, the first set of carbon results, soil carbon results, showed no significant differences. It could be awkward if you hadn't even really imposed any treatments and you find there's a difference anyway. So that's the first set of results. Then the following results are still awaited. Very interesting to see what changes we get and how fast they may come about. It's obviously not an instant effect trying to build up soil carbon. So, the prediction is that hopefully zero till, certainly in the longer rotations, will build up carbon. A little bit negative there on the theory, whether that might stay the same. It may go up with zero till. We'll see how that goes. So one of the questions that a lot of people ask, of course, is worms. Very interesting, both with zero till and with the addition of cover crops. So this is after only 1 year of running the treatments, and we're already starting to see some differences. I think particularly interesting is on the right-hand side that just from the first year of using a cover crop, we have a statistically significant difference with more worms. This is total worms. They were split into different types, but this is just total for a quick look-see. Yeah, there's a lot of variation there on the left-hand side with the cultivation and the rotations. So nothing too much we can say there. We'll see if they're going to continue to rise with zero tillage or maybe not. It's all there to be found out. And that's all I have to say at the moment.
Thank you, Ian. Nathan, are you ready?
Yeah, I'll just share my screen
we'll be doing
now.
all the questions at the end.
Okay, can everybody see my screen?
We can see you in present mode.
Is that better?
Perfect, thank you. Yeah.
Brilliant, thank you very much. Okay, so yes, I was just going to do a little bit of an overview on how I see and some of the research that has been going on in the UK around cover crops and their use within farming systems and building a resilient farming system. So I thought I would just start with what do I mean by a resilient farming system? And I think with the more recent changes in weather patterns and the intensity of rainfall, more extreme conditions in terms of periods of dry, periods of heat, has increased very much our challenges around crop production, and therefore any way we can look at trying to build resilience into our system, be that through what I've put here, some things like healthy soils. So as we've just been discussing, trying to build soil organic matter in the soils, trying to improve the soil structure to aid drainage, increasing biodiversity. So we can be a bit less reliant on inputs for pest control. There's a big, obviously, emphasis at the moment around our water quality, and trying to keep the water as clean for drinking water and other uses. And then there's building the climate resilience, and more importantly, I've put it last, but it really shouldn't be last, but it's maintaining profitable farming systems as well. So, and I thought the diagram on the right is quite a nice way of summarising how all those integrate together. So cover crops I see can be part of that, but by no means they should be seen in isolation. These farming systems are always, like a jigsaw puzzle of those jigsaw pieces fitting together to make that system. So I thought I'd just do a very brief review, and there was a very a good review done with AHDB a few years back that looked at all the information that was available at the time in terms of cover crops, what they basically can do in terms of potential benefits, and there's a very long list there. I won't go through them all there, but certainly things around nitrogen fixing and uptake, minimising losses to water, soil erosion and soil cover is very important, particularly over winter months, to reduce that runoff and loss to watercourses, and the general improvement in the soil health and soil structure around those roots, and obviously earthworm activity, and just building those sort of blocks, if you like, for improving our resilience. There are, of course, challenges as well with cover crops. And these are just a few. I'm sure there are others as well, but there are obviously challenges, particularly around rotational use of cover crops and how those might implicate on our cash crops in terms of green bridges, potential weed challenges as well, how we manage volunteers as well in the following crops, and obviously some of those management issues, particularly around both destruction of cover crops and the establishment of following crops on heavier soils can be more of a challenge than on our lighter soils. And of course, as we've all just heard from Ian, that there is an increase in terms of cost and workload with additional operations for establishing cover crops. And the benefits are not always immediate, and I've got some results that will just hopefully show that in a bit more detail. So as I mentioned, cover crops are certainly a very important part of our farming system, but of course they do add complexity. And again, I quite like this graphic that just showed just some of the perhaps decision-making thoughts that might need to be adopted if we're considering using cover crops in our farming systems. So things like how long do we want the cover crop in the soil for, the cost of both the seed and the establishment, compatibility within our farming system, so in terms of soil type, in terms of our crop rotations. So there's a number of considerations there. We do know from research that cover crops are very good at basically keeping nitrogen out of water, and this was just some examples from various studies that have been done over the years with a number of species. There's obviously not an exhaustive list, there are others. But there are good examples here of just how much nitrogen can be taken up over, this is typical, what we say, over winter. So that sort of typical period, post-harvest, cover crop established in sort of mid-August onwards, and then over that autumn, winter period before spring crop, where the ground could be left bare and be more at risk from nitrogen loss. So having a cover crop with a root system that's able to take up that nitrogen and keep it out of the water can be very beneficial. And you can see there at the bottom, we've got two brassicas, both white mustard and oilseed radish. Both of those are particularly good at taking up nitrogen out of the soil. Nitrogen release obviously is a bit more complicated, and that will be a separate discussion. But there are differences in terms of when those release characteristics occur, and it's partly driven from the carbon nitrogen ratio of the material or the species grown. So essentially material that has higher lignin. So example, rye actually has quite a high lignin content, and the CN ratio is also quite high, and that essentially degrades and breaks down more slowly. Therefore, the release of nitrogen can be slower than some of the other examples. For example, those brassicas, which tend to have lower CN ratios. But as I said, they are cover crops can be very useful at picking up nitrogen and keeping it out of the water. And there was some really good work done as part of a DEFRA project that was the demonstration test catchment project that had a number of different catchments across the country. The one I've just got here as an example is from the Wensum, which is in Norfolk, and it was led by the University of East Anglia, where they had very, very good monitoring using kiosks to look at water quality over a catchment of a farm. So it was a number of fields on farm that they monitored under different management regimes, so with cover crops, with different types of cultivation, to look at the water quality in terms of in here in the blue, the sort of middle bar is the nitrate data. The top bars are the rainfall, and then the bottom lines in red are the phosphorus content. But the nitrogen is very clear to see the benefits from cover crops at really lowering the risk of losses to water. And in this study, there was a 75 to 97% reduction relative to a plough-based approach in reducing nitrate losses. The phosphate wasn't as clear. There was not such a strong link with the use of cover crops, but the nitrogen was particularly good at keeping the water clean. Cover crops are also very good with rooting, and rooting obviously is really important both for sort of soil structuring, but also sequestering carbon in that soil as well. And this was an example from a study from a PhD student who was looking at one of the long-term studies that NIAB manage down at in Suffolk. This is the Sustainable Trial and Algal Rotations project that's now in its 19th year, and we were looking at how different management in terms of cultivation and rotation could influence the structure of the soil. So the student looked at 2 rotations, so that was continuous wheat and alternate fallow, and then looked at 3 cultivations, so plough, deep non-inversion, which was about 250 millimeters depth, and then shallow non-inversion that was about 100 millimeters depth, and then used various measures, soil measures, things like penetration resistance, bulk densities, to look at the structure of the soil, and took cores down to a meter that then were processed using X-ray chromatography to look at the pore network. And that's what I just wanted to give an example here. So here are some examples of those images, and these are under different. So we've got shallow, deep, and plough as our cultivation approaches. CWW is continuous winter wheat, and then the ALTCC is the alternate cover crop. And then you can see there the difference in the pore networks. Particularly striking really is between the plough alternate cover crop with quite large pores, but not very many of them, compared to shallow cultivation with the alternate cover crop, where you've got that very, very fine network of pores, and that interconnectivity really helps with drainage, the rooting ability, and hopefully in terms of access to both nutrients and water for crops as well. Another example that's just looking at building resilience into a system is a piece of work that's undertaken at Morley in Norfolk. and it's funded by the Morley Research Agricultural Foundation and the J.C. Mann Trust, and it's been running since 2007, and it's what we call the New Farming Systems Cultivation Experiment, and it has two main factors that we're looking at. So cultivation, so we have 4 levels of cultivation, from plough being the most intensive through to deep and then shallow non-inversion, and a managed regime, which is basically adapting to the conditions and also the management history in terms of any grass, weeds or other factors that farmers would do. And that's very much an example of how farmers will react to the conditions, rather than just being absolute to a single type of cultivation. And then on top of that, we have 2 management approaches. So we have current, which is basically following a winter cereal based rotation. And then we have one that's a cover crop. So again, winter cereals, but when we have the spring breaks, we follow that with a cover crop. And you can see there, over the period of time, we've actually had a number of iterations of cover crops, and that's particularly interesting when we start to look at the performance. So this is just comparing, this is percentage of yield response to the cover crop in 2 of the tillage. So they've sort of picked out the extreme cultivation. So we've got plough tillage and we've got shallow tillage. Plough tillage, you can see there, and this is, again, the bars are not in date order, they are actually ranked in response order from the least to the most. But you can see there that plough tillage, generally, we don't see a response to the cover crop, and that's essentially because the cultivation is actually doing that structuring of the soil, compared to in shallow tillage, where obviously we're minimizing that disturbance with a cultivator. We're actually getting the benefit from those roots in the cover crops, and therefore we see that response to the cover crop in more years than not. If we delve into that a little bit more detail, and I apologise, this is quite a detailed slide, but I think it's worth just spending a little bit of time just to look at the interactions between the different cultivations and the response. So this is yield as a percentage of control, and the control is essentially the plough without the cover crop. So I basically look at each yield in every year and say the plough without a cover crop is 100%, and then I look at the other yields as a relative percentage response to that. So we can see that where we've got deep and shallow cultivations, we do see a slight drop in performance on average compared to ploughing. Where we have cover crops, again, with the shallow cultivation, we see without a cover crop, we do see a drop in yield performance. With a cover crop, we start to see a bit of a build up across the whole period of the rotation. But you can see there from the range of responses, we can see there that actually both the cultivation in terms of non-inversion tillage and the use of cover crops can actually increase that variability over the period of the 10 years that this data's been looking at. But that perhaps hides some of the issues that actually, if we look into the data a bit more, we actually start to see where those responses are coming. So we can pull out essentially the years that the winter wheat, and we can actually see that winter wheat is a very robust crop. We don't see much of an effect from the rotation or the cultivation, apart from where we've got the shallow non-inversion without the cover crop. But the other, both deep with or without cover crop and the shallow with a cover crop, give very similar to performance to a plough-based system. We can also look at the same data, but in terms of periods. So I've basically looked at the data from years 2 to 6, so essentially the early years of when the cover crops have been used. And then I compared that to the latter years of the study. So years 2 to 6 are the first 5-year periods, and then years 9 to 13 of the latter 5 years. And we can see what's really interesting there, how there's a drop initially with the deep and shallow, and particularly where cover crops were used, there was a drop in the performance. But in the latter years, we've really seen those picking up and becoming much more comparable to the plough-based system. So again, we were talking about the use of cover crops, and that basically to build a resilient system, actually it's that repeated use of them in the rotation where we start to see those longer term benefits. We can obviously look at margins because, again, as I mentioned at my beginning of the presentation, financial performance and the profitability of a farm enterprise is really important. And we can see here again, obviously there is a cost associated with the cover crop, and particularly where you've got the additional costs associated with establishing those, we do see some drop in margin. Although the shallow cultivation with cover crop does, with the yield performance improving, obviously that helps with that return. And when we look at the actual support payments that hopefully can be used to support the use of cover crop establishment and seed cost, we can see actually we're pulling ahead a bit in terms of margin performance. One last thing I wanted to cover, because I think it's quite an interesting thing, and it's a slightly different way of looking at data compared with just the sort of yield or margin output. We can actually derive how much energy is required per tonne of production. So we call it the energy input ratio. And this was done kindly by some colleagues at the University of Hertfordshire. And this is just a brief summary of essentially we derive both direct and indirect inputs and look at the energy associated with those materials. And then we look at the energy input ratio, which is basically the division of essentially plough-based approach in the given year against whatever other comparator is. So, for example, a non-inversion with or without the cover crop, to look at that effect. So here we've got the ratio. So again, we've used plough as our control without the cover crop. So that ratio is 1. So it gives us a performance. So anything above 1 essentially requires more energy to get a tonne of output. Anything below 1 is actually a more efficient way of getting that output than a plough-based system. We can see here that the years from 2008 through to 2020 are seen on the left there with the particular crop. The spring cropping is highlighted in blue, and we can see there in the early years we've highlighted the ratios that are above 1 in pink or red, and you can see there that there's quite a lot of predominance of those higher values, particularly in the use of cover crops. Those essentially the extra operations of the cover crops didn't actually give us that reduction in energy ratios early on. But as the rotation progressed over time and more iterations of cover crops were used, we can see those numbers turning to green. So actually, over the longer term, we see improved performance with lower energy required. And you can see there quite nicely the performance of the shallow non-inversion, giving some really good performance based on the energy required per tonne of production. So we might get a very slightly lower yield, but we actually improve our energy efficiency of the system. And the last bottom lines on these on this table are looking at the rotation either with or without the winter wheat years in either from 2010 onwards or from 2015 onwards. And again, it's just to see that shift over time that we saw with the yield, that obviously we see actually coming through when we calculate the energy input ratio. So we can see there that the deep non-inversion with cover crop in the early years was actually giving us a ratio just slightly above 1, but in the latter years we've actually seen that drop below 1, and that improvement seems to have occurred over those latter years of the study. So just a few messages I wanted just to highlight in terms of how we use cover crops to build resilience. And as I mentioned, cover crops can really be beneficial in terms of providing nitrogen uptake, erosion control, soil structural benefits. We need to be probably quite specific on our objectives and consider the rotational impacts, and therefore choose our species that we want within our rotations carefully. In terms of the cover crops, the recovery of nitrogen can be anywhere between 25 and 90 kilos of N, and that's at current fertiliser prices can be worth up to £100 a hectare. We've seen improvement in soil structure and pool connectivity that cover crops can add additionally to a system, particularly in conjunction with tillage approaches as well, with looking at moving less soil disturbance. And then the longer term yield improvement, yield stability and lower energy input per ton of production is again something that does take time. It's not something that changes very quickly, but over the course of rotations you start to see. So my main message really is that cover crops are an investment across the rotation, and that cover crops are part of really building a resilient farming system, but must not be seen in isolation. They must be part of that holistic approach to cultivation, increasing crop diversity, improving soil structure through maybe a use of amendments, etc. So thank you very much.
Thank you, Nathan. If anybody has any questions, feel free to put your hand up or put them in the chat. But I will go ahead with a couple. So one for Ian is, what depth are you measuring your soil organic carbon to?
Was that depth?
Yeah.
Yeah, to 1 meter. So it's split into the plough layer, because historically even the zero till was ploughed until recently. Plough layer, and then plough layer down to 60 centimeters, and then 60 to the meter. Yeah.
Okay, great. And also, how do the baseline soil organic carbon levels for your two sites compare with a typical arable rotation on the same soil type?
I would say they're pretty much in line, because they were in the typical rotation until we laid out an experiment on top. So those baselines are what the previous rotation has given us, and yeah, they're pretty much in line. So they'd be a bit higher. The data on there was from Broomsbarn. They'd be higher at Harpenden. Obviously, the higher clay content at Harpenden allows that soil to hold on to more carbon than the sandy loam. But yeah, fairly typical.
Thank you. We've had a question in the chat from Ian Wilkinson for Nathan, and it's, are you monitoring earthworms as a part of your work?
Sorry, can you just repeat that question?
That's right. Are you monitoring earthworms as a part of your work, like Ian?
So we have been. We've done some measurements. We've learned that obviously there is quite a driver from the conditions at the time. So it's a sandy loam soil at Morley, and that can be, depending on the conditions. So essentially, the seasonal effect can be a bigger effect than the actual treatment's effect. But we do look at earthworms, and we do see a general trend to, not always statistically significant, but a general trend to higher numbers in the lower disturbance systems. Not necessarily such an effect from the cover crops, but the species we've used aren't necessarily ones that have very high biomass, and therefore that might influence a little bit about how much effect that would then have on earthworm numbers. But we do certainly see a general increase in earthworms, and particularly when we look at the sort of species of worms, so not just total numbers, but actually what we say the functional groups. We do then start to see differences in terms of those species present because of that cover that cover crops and therefore food supply that those cover crops offer.
Yeah, thank you. And then another question is there anything that could be done to reduce the variability seen in the year-to-year benefit from having cover crops in the rotation?
That's yeah. Yeah, that's a really good question. I think that's one of the things, I guess, as researchers and scientists, we're sort of working on in terms of getting additional data so we can really learn where actual things work. But it is challenging because obviously seasonal differences and also our diverse cropping and climatic conditions in the UK actually mean, even if we're doing an intensive monitoring at long-term monitoring on certain experimental sites, it's not necessarily going to be the same on all farms in all scenarios. So it becomes a little bit more tricky. But yeah, I do see, as I say, use of cover crops being part of the system. I think we've got to be careful not to put too much reliance on just cover crops. if we are looking to build resilient systems and trying to reduce that variability, we've got to look at our cropping systems in terms of rotation, the cultivations, use of maybe integrating livestock if we can. I know that's not always easy. But there are, it's just like one of the tools in the toolbox. But trying to integrate them all obviously does take more management and time to actually get them together.
Yeah, thank you. I have a question for Ian. How do you decide which species to include in your mixtures?
Yeah, I mean, it could have been so many things. The more complex mixture in the longer rotation was actually it was available. It was marketed at the time when we first picked it up, and we thought it looked interesting. It's since been withdrawn. We can't actually get it anymore, so we're having to mix it up ourselves now, just for continuity, to keep the mix the same. It's quite complex, and that's an interesting question. Do you need to have that many different species in there? The work will not address that. It is only looking at a really quite diverse cover crop, and it's only looking at that in combination with the other factors. So in line with that rotation being diverse, we picked a diverse cover crop mixture. And in line with the shorter 5-year rotation being less diverse, we picked a less diverse mixture for the cover crop. And as I said, keeping brassicas out of the cover crop where we're growing oilseed rape, just for a little bit of safety. Jasmine's still there. Has she frozen?
Maybe she's frozen.
Yeah. Are there any?
There's another question that seems to be towards aimed at me, which is good. So there's one that's basically asking if there are certain cover crops that would have more benefits towards arable farmers with control of things like blackgrass and pests such as flea beetle. And that's, I think at the moment we're probably still learning. I think there certainly are in terms of blackgrass control. If you are on very heavy soils with a predominance for blackgrass, then we have to think carefully about how to integrate cover crops into those rotations. Something that's particularly with blackgrass is challenging if you've got a very thick cover crop, because you want to try and suppress the blackgrass, and you can end up with a challenge of then when you come to destroy that cover crop, that essentially the cover crop's actually just shielding the surface where the blackgrass is. And you have to end up with potentially several applications if you are destroying with glyphosate, which is still the main destruction method for cover crops, and is a challenge, I think, industry where reliance on glyphosate is particularly difficult. Things like flea beetle, I think there is lots of work going on, but I don't think we've got something that's specific yet to say that cover crops or particular species of cover crops can help reduce flea beetle pressures. Unfortunately, it'd be nice if we could.
Are you back? You're back again, Jasmine.
Yes. Sorry, I disconnected. I think it started raining. Did you answer Robin's question? I cut out before I got to ask it. Organic and carbon assessment methods and metrics. Did you answer that question?
Yeah, we haven't looked at that one yet. No.
Okay. Well, Robin has asked which is the preferred carbon and organic assessment method and metric.
Well, at Rothamsted, we're using leco combustion to find total carbon in the soil. And when it's Broom's Barn soil, we actually have to move inorganic carbon with an acid because there is visible limestone in the soils at depth. So we remove the quantity of inorganic from the total. LECO gives you the total, and we take the inorganic away just to see organic carbon. We present that usually as a proportion of the soil mass, but of course you can also then work with bulk density to look at the total carbon store in the soil. And we are measuring bulk density at the same time to be able to do that.
Okay, great. Well, I think we can finish the questions there. Before everyone goes, I just want to thank everyone for listening and for the questions. And if you'd like to sign up to the newsletter that Ian mentioned at the start, I have put the link in the chat, and I've also put the email in as well. So if anyone thinks of any questions, please do not hesitate to email us at the CHC3 email. And we have got a 5 o'clock webinar coming up featuring flax and hemp on the 13th of December. If you would like to sign up, it's the same link as the newsletter. So thank you very much, everyone, for attending, and hopefully we'll see you soon. Thank you.
Yep, thanks everybody.
Thanks very much. Thank you.
Thank you, everyone.
Thank you.
Thank you.
Thanks. Cheers all. Thank you.